A photon with frequency 5.8 times 10 to the 14th hertz collides with an electron at rest. The electron absorbs the energy E. The important part here is that we're absorbing energy, right? We don't really care about the collision. Like I told you guys before, this thing colliding with an electron, that's not the important part. You don't have to go looking for collisions with electrons. That's not the important part. Don't worry about that. What is important is that we're absorbing an energy E when we absorb that photon. But before we even get into that, let's look at 12a. I guess technically though it's 11a because that's 11. I don't know. I deleted the question and it got all messed up. But 12a says identify the color of light that is associated with this photon. So the color of light is determined by the frequency of that light, right? One frequency of light will give you one color. Another frequency of light will give you a different color. In this case, we have a frequency of 5.8 times 10 to the 14th hertz. What we have to do is look at our electromagnetic spectrum. And what we see is that a bunch of different frequencies are given to us down here. Up here are our wavelengths. We don't need to worry about those, or at least not for this question, right? But we see that the frequency of 5.8 times 10 to the 14th power lies somewhere around right here, because here's 5.2, here's 6.1, so it has to fall somewhere in the middle, like right there, 5.8 times 10 to the 14th hertz. It has to be right around there. Then what does that mean? That means it falls under the category of green light, because it falls below where green light's range is. So what color of light do we have? We have green. That is the worst G I've ever drawn in my life, but I'm leaving it. Calculate the amount of energy E absorbed by this electron from the photon. Well, we know that the energy of a photon, E photon, equals Planck's constant times the frequency. Planck's constant is, as it's called, a constant. Right? It's given to you on the first page of your reference table. This thing right here, H, it's always going to be the same value. You look at page 1 of your reference table, you see it's equal to 6.63 times 10 to the negative 34th power joules times seconds. And the frequency is 5.8 times 10 to the 14th power hertz. You multiply the two of those, and what you're going to wind up getting, let's see, 6.63 times 10 to the power of negative 34 times 5.8, I'm plugging in my calculator right now, times 10 to the power of 14, I wound up getting 3.85 times 10 to the power of negative 19 joules. That's your final answer. That's the amount of energy absorbed. If you collide with a photon of that much energy and you absorb it, you're going to absorb all of that energy of the photon.